Hi guys, welcome to another session of data structures. Today's concept is called queues. So a queue is a linear data structure that follows first in, first out principle. Okay, so you know that like queues are nothing but we see queues in day-to-day life at different places like at reservation counters, movie theaters, or at bus stands, railway stations for taking tickets or any goods or something like that. So what is the concept is like it operates like a line where elements are added at one end. Okay, so if someone is coming and want to stand in the queue, so they'll go and stand at the rear of the queue, that is the end of the queue. And whoever is the front of the queue, so they'll take the goods or they'll take the ticket and they'll come out from that queue. Okay, so that means the insertion takes place at the end, whereas the deletion takes place at the beginning. So the place that you do insertion is called rear. The place it do deletion is called a front. Okay, so these two names are used to represent beginning, that is front, and end, that is called the rear. So what are the different properties of the queues are like? We define a queue to be a list in which all additions to the list are made at one end, back of the queue, and all deletions from the list are made at other end, that is front of the queue. So the element which is first pushed into the order, the delete operation is the first performed on that. That means, if someone is standing in the queue and he's the first one in the queue, so he is the one who will actually leave the queue. Okay, so we call it as a first in, first out. So FIFO. FIFO is an abbreviation for first in, first out. It is a method for handling data structures where the first element is processed first and newest element is processed last. So what are the real life examples of queues? Okay, you can just look at this figure. Like there is a ticket counter and a person sat at a ticket counter. He is known as ticket checker. Okay, so there are some people who are standing in the form of a queue or a line. Okay, so the first to get ticket and leave is the oldest person. That is the first in the queue. And similarly, there is a second person, third person, and the newest person who entered into the queue is standard the last. So he is the one like to get the last ticket and leave. Okay, so by just looking at this figure, you can easily understand what we mean by a queue and all. So there is a ticket counter where people come and take tickets. So people enter a line to get the ticket counter in an organized manner. The person who entered the queue first will get the ticket first and leave the queue. Then the person entering the queue next will get the ticket, and after the person in front of him. In this way, a person entering the queue last will get the tickets last. Therefore, the first person to enter the queue gets the ticket first, and the last person to enter the queue gets the tickets last. So this is known as the first in, first out, or FIFO. So like a representation of queue with data structure. So you just look at this figure like. The beginning of the queue is represented as front or head, and the end of the queue is represented as back, tail, or rear. Okay, so when you want to remove some elements, you do it from the front. Okay, so you call it as a DQ operation. If you want to insert elements into the queue, we do it at the rear, and you call it as a NQ operation. Okay, types of queues. So there are different kinds of queues are available. Okay, so the first one is called the simple queue. Simple queue simply follows the first in, first out structure. We can only insert element at the back and remove the elements from the front of the queue. And there is another queue called double-ended queue, deck. Okay, so in double-ended queue, the insertion and deletions both can be performed from both the ends. They are of two types. Like if you just insert only at one end, you call it as input restricted queue. So deletion can be performed on both the ends. Similarly, there is another kind of a deck, a double-ended queue, that is called output restricted queue. So that means you remove the elements only from one end, but insertion can be done at both the ends. That is output restricted. And there is another queue called circular queue. So circular queue, as its name says, this queue form in the form of a circle. Okay, so this is a special type of a queue where the last position is connected back to the first position. So here also the operations are performed like a first in, first out order only. And there is another kind of a queue called priority queue. So as its name says, a priority queue is a special queue where the elements are accessed based on the priority assigned to them. There are two types of priorities: ascending priority queue, descending priority queue. So in ascending priority queue, the elements are arranged in increasing order of their priority values. Elements with the smallest priority values is popped first. Similarly, there is a descending priority queue. In descending priority queue, the elements are arranged in descending order or decreasing order of their priority value. So elements with the largest priority is popped first. And what are the different operations we can perform on queues? So some of the basic operations are NQ. NQ means adding elements to the end of the queue, and there is a DQ element or removal of elements from the queue, which was done at a front. And there is a peak or a front. That means we can acquire the data elements available at the front of the queue without deleting it. And rare, so that means we can check what is the element at end of the queue. Okay, so and we can perform is full and is empty operations. Is full means validate if the queue is full. Is empty checks the queue is empty. And we can also perform a size operation, finding a number of elements in the queue. So array can be used to implement the queue. So because this is a simple operation where we use arrays to implement queues. So for implementing queues, we need to keep track of two indices like front and rear. We enqueue an item at the rear and dequeue items from the front. If we simply increment front and rear indices, then there may be a problem. The front may reach end of the array. The solution to this problem is to increase the front and rear in circular manner. So the solution for the problem, like when you delete elements, your front actually try to move in the uh, right direction. That means it slowly runs towards end, or that means rear, and it finally meets the rear. Okay, but even though there are some places at the beginning you can't access them, so to access them it's better you connect the queue as a circular queue. That means the rear is connected to the front, so that you can use all deleted elements places. So that is a solution with the circular queue. So how do you perform this NQ operation? So we check that for NQing or pushing elements, first we need to check whether the queue is full or not. If the queue is full, we can't insert elements into it. Okay, so we call it as an overflow condition, and we just exit from the operation. If queue is not full, what we do is like we just increment tail and add the elements. Okay, and similarly for DQ operation or removing elements, first we need to check whether the queue is empty or not. If the queue is empty, so we say like the queue is in underflow condition, and we just exit from the program, and we just close the program. If it is not empty, so we print the element at head or front and increment to the head or front. Okay, and this is the code where we can perform this queue implementation. Okay, by using this list type. That means like arrays concept and all. Okay, so in this program I have taken the capacity or size of the queue as 5, and we have written different methods for checking whether queue is empty, and how do you do this NQ operation. Okay, and all, and DQ operation. We need to perform the what is the element at the front, what is the element at the rear, and what is the size of the queue and all, and how to display the queue and all, right? So this is like a menu kind of a program wherein we have prepared some options like NQ, DQ, front, rear, size, and display operations and all. Okay, so we just ask for the choice of the user. If choice is 1, we perform NQ operation. If choice is 2, we perform the DQ operations or deleting the elements. If choice is 3, we say like what is the element at front, and if the choice is 4, we say what is the element at the rear, and we choice is 5, we find what is the length of the queue, that is how many elements are there. And if the choice is 6, we just display the contents of the queue. And finally, if choice is 7 or something else, we say like we exit from the menu program. Okay, so this is an implementation of the queue by using arrays. Okay, so I'll just show you the execution part. Okay guys, this is the queue program implementation of queue by using arrays, and in Python we don't have arrays concept. So we use the list concept. Okay, so you can see that there is a class called queue, and that constructor, that is init method, where we have taken queue as an empty list, and the capacity or the size of the queue will be 5. And there is an operation that like a method to find whether the queue is empty or not. And there is different operations like enqueuing an element and dequeuing an element, peak, that is identifying what is at the top of the queue or not, what is size and display. We created a kind of a menu program and all. We ask for the choices from the user. Like we just check it like how this gets executed. So here you can see there is a menu options like NQ, DQ, front size is turned on. Okay, I'll enter the option one, choice one. So it asks for the data. So 10, I am giving 10. So I'll just check it whether my 10 is entered into the queue or not. Okay. So you can see that 10 is there in the list or array. Okay. Then I say another choice is one. I enter another element called 20, and again I take the choice one. I enter another element called 30. Now I'll check whether my elements are there or not. Okay, so you can see that 10, 20, 30, all the elements are in that queue. Okay, so I'll check it what is the front element. So I'm giving the choice as 3. So the front element is the 10, that is true, and I'll check what is the size of my uh, queue. So I have given the choice as 4. So you can see that the length of the queue is 3 because there are only 3 elements. Okay, I'll just display all my elements. You can see that 10, 20, 30. Okay, that's it. And then I'll just do the DQ operation. So 2. So you know that dequeuing means removing the first element from the list. You can see that there is a queue is having a 10, 20, 30. The first element is 10. So I should get 10 is removed from the queue. So we'll just see the delimited element is 10. So it successfully removed 10. So we'll just cross check it whether it's actually performed or not. So we again display the contents. So option 5. So 10 and 30, 10 is removed and 20 and 30 has been there in the queue. So this is the queue implementation using arrays. Hope you understood the concept. How this video is